The highlights of today's defense news, 5th of November 25. L&T-BEL induct Dynamatic Technologies for AMCA project. Dassault Aviation expands its engineering center in Pune. India and Israel ink agreement to share, co-develop and co-produce advanced defense technology. IIT Gandhinagar and Army sign MOU for armament research academic collaboration. Adani IWI's PLR systems sole contender to clear NSG trials for 7.62 by 39 rifles. Zuppa and Divide by Zero launch India's first 3D printed mobile drone fabrication units. CoBRA Group refines Rafale tactics to outmatch Pakistan's J-10CE acquisition. 1 lakh crore rupees RDI mega fund to drive India's deep tech and innovation revolution. Thales to station permanent representative at Ambala Air Base for Rafale maintenance. HAL and Government of India funding structure for deck-based multi-role helicopter development. Tata Advanced Systems to collaborate with W&E Platt on Uncooled TI sites. IIT Bombay engineers pioneer GPS-free swarm control system for VTOL drones using camera-based bearings. L&T expands nuclear power capabilities with Holtec partnership and defense collaboration. DST's technology board backs Westech Power's indigenous energy storage project. In the global highlights, HII and Shield AI test Romulus unmanned vessels in successful AI-powered sea mission. Finland moves towards data-centric warfare with Nest AI collaboration. DARPA awards drone contract to develop bird-like soaring. A look at the news in detail. A consortium comprising Larsen & Toubro and Bharat Electronics announced the induction of Dynamatic Technologies as its exclusive partner in the development of the AMCA. The alliance leverages DTL's extensive experience in manufacturing complex aerostructures and subsystems for leading global aerospace original equipment manufacturers, combined with L&T's engineering excellence in high technology manufacturing and BEL's cutting-edge electronics and avionics systems. Together, the three firms aim to give India a formidable domestic manufacturing capacity for advanced aerospace platforms. Dassault Aviation is extending its presence in India by inaugurating the new premises of Dassault Aircraft Services India Engineering Center in Pune. The expansion of the engineering center, which will double its capacity to accommodate more than 150 engineers, demonstrates Dassault Aviation's determination to develop cutting-edge technological capabilities and foster local expertise for the benefit of its internal operations as well as those of its Indian and global supply chains. It also illustrates its commitment to meeting the offset obligation set out in the Rafale contract with the Air Force. Created in 2018 in Pune, DASIEC is an operational and mature structure that oversees Dassault Aviation's engineering activities in India in both the civil and military sectors, capitalizing on a core set of skills based on the company's Indian partners. From design to production and support, the entire aircraft lifecycle falls within its scope of activity, all as part of an extended design office approach. By strengthening resources and developing local expertise, the aim is to support the transfer of Rafale and Falcon production to India, which is experiencing considerable growth with the signing of several major agreements with leading Indian partners in the recent months. India and Israel inked a memorandum of understanding to share, co-develop and co-produce advanced defense technologies. A wide range of areas for cooperation have been identified in the MOU that will benefit both countries. Important fields include strategic dialogues of mutual interest, training, defense industrial cooperation, and capabilities including science and technology, research and development, and technological innovation, artificial intelligence, and cybersecurity cooperation. The MOU will enable the sharing of advanced technology and would promote co-development and co-production. Indian Institute of Technology Gandhinagar and Indian Army, through its Electronics and Mechanical Engineering School in Vadodara, signed a memorandum of understanding to collaborate on armament technology and academia with a view to solving problems for the armed forces and conduct a student exchange for educational enhancement. This is the second most recent MOU by IIT Gandhinagar in the defense sector, having signed a pact with Adani Defense and Aerospace in May 24, was, which was for product oriented to provide technical support in defense. Chennai-based Zuppa and Navi Mumbai-based Divide by Zero have joined forces to unveil India's first 3D printed mobile drone fabrication unit, marking a major technological milestone. These modular fabrication units are designed as containerized, rapidly deployable systems capable of manufacturing drones in real time directly at operational sites. Using DBZ's industrial grade additive manufacturing technology, the units can 3D print airframes and key components, which are then assembled into mission ready drones through Zupa's autonomous drone platforms and AI integrated control systems. By enabling on-demand drone production near deployment zones, the system reduces operational downtime and reliance on large centralized supply chains. It allows defense and disaster response teams to fabricate or repair drones tailored to specific mission profiles, from surveillance and logistics to combat reconnaissance, without returning to rear bases. This approach brings significant strategic flexibility and enhances operational resilience in dynamic environments. Indian Air Force's Elite Combat Battle Readiness and Assault CoBRA group has finalized an advanced set of air combat tactics that significantly enhance the operational lethality of Rafale squadrons. These new doctrines transform a standard four-ship Rafale formation into a cohesive strike web capable of overwhelming larger adversary groups of 6 to 8 PAF J-10CE fighters through superior sensor fusion, data link coordination, and optimized beyond visual range engagements. At the heart of this approach lies an evolved framework of airspace coordination. The Rafales operate in staggered combat pairs, maintaining flexible spacing to exploit their advanced AESA radars and secure data links while maintaining mutual sensor coverage. Real-time fusion of radar inputs, infrared search and track data, and spectra electronic warfare cues allows the lead aircraft to manage situational dominance even in saturated threat environments. Utilizing the Thales Spectra suite and the onboard F3R F4 standard OSF system, each Rafale becomes an active node in the combined battlespace cloud. The CoBRA doctrine ensures that no single aircraft is solely responsible for target detection or tracking. Rather, the entire formation functions as a single sensor entity. This substantially improves survivability and reduces the risk of surprise engagements from multiple vector directions. BVR tactics have also evolved under this framework. The Rafales execute layered missile launches designed to overwhelm enemy countermeasures through staggered timings and multi-axis approach profiles. While Meteor missiles serve as the primary offensive tool, Mica variants provide shorter range closure defense, turning each engagement into a trap of timing and maneuver sequencing unfavorable to the J-10CEs. Force integration is a defining strength of this model. The Rafales maintain live data exchange with airborne early warning and control aircraft and ground-based operations centers. This ensures that the target acquisition and priority threat tagging begin long before visual range, granting the Air Force formations extended planning, lead time, and dynamic retasking flexibility. Such integration allows Rafales to enter conflict zones with superior situational awareness and exit before enemy formations can coordinate an effective response. Further refinement by CoBRA includes new coordination drills designed for mixed formations involving Su-30 MKIs and Tejas Mark 1As, reinforcing cross-platform synchronization. This allows Rafales to act as forward controllers for heavy air dominance platforms, directing missiles and decoy launches with precision while minimizing exposure. Hindustan Aeronautics will co-finance the Indian deck-based multi-role helicopter program along with the Government of India, establishing a strategic funding partnership aligned with India's indigenous rotorcraft roadmap. HAL will contribute 30% of the project cost from its internal resources, reinforcing its commitment to self-reliance in advanced helicopter technology. The government will provide the remaining 70% through capital allocations once formal clearance is secured. The funding arrangements remains contingent on approval by the CCS, which will evaluate whether the DBMRH aligns with the overarching Indian multi-role helicopter framework. This step ensures that the naval variant evolves in synchrony with the main IMRH program, avoiding duplication and optimizing design and production synergies across the rotorcraft family. The CCS review will also consider the program's integration with the Aravali engine joint venture between HAL and Safran. The synchronization of the DBMRH development timeline with that of the locally manufactured Aravali turboshaft engine will be critical in achieving full indigenization for both land-based and naval variants. Tassel is set to partner with Australia-based W&E Platt for the co-development and production of uncooled thermal imaging weapon sights. The collaboration aims at leveraging Tassel's growing optronics capabilities with W&E's Platt's expertise in thermal sight technology to deliver advanced surveillance and targeting solutions. These uncooled TI sites will be designed for integration, providing clear imaging in diverse operational environments without the need for sensor cooling systems, simplifying both logistics and maintenance. Through this partnership, both firms intend to target markets in India and abroad, including potential use by military and law enforcement units, which require compact, reliable thermal solutions for weapons and platforms. The agreement also signals a strengthening of Indo-Australian defense industry ties, enabling local manufacture, technology transfer, and joint innovation in critical optronics. Researchers at the Indian Institute of Technology, Bombay, have introduced a breakthrough control scheme enabling unmanned aerial vehicles to fly in coordinated swarms without depending on GPS, inter-drone communication, or centralized control. Developed by Professor Dwaipan Mukherjee and research scholar Chinmay Garanayak, the system relies entirely on bearing only measurements acquired through onboard cameras to maintain relative positioning and formation. The newly proposed bearing-only control paradigm allows each drone to observe nearby units using its onboard camera, deducing bearing information to sustain formation alignment. The goal of bearing-only control is to achieve formation coordination using only inter-agent bearing data. This eliminates the need for GPS or communication with other drones or a central processor, resulting in a lighter and more power efficient design. Larsen & Toubro has signed an MOU with Holtec International Asia Arm for design and build solutions for heat transfer equipment in the nuclear power sector, advancing SMR 300 deployment. This builds on their existing partnership for SMR 300 deployment. The partnership aims to combine L&T's world-class nuclear manufacturing capabilities with Holtec's pioneering design expertise to deliver cutting-edge solutions for nuclear and thermal power plants worldwide. The focus will be on developing technology that can optimize thermal regulation, maximize cycle efficiency, and ensure reliable power plant operation. News from DARPA. DARPA has awarded Autonomy Developer Physics AI a contract to design, train, and test AI-enabled soaring capabilities for drones. The prime contract was placed under DARPA's Albatross program, the agency's initiative to develop autonomous soaring capabilities to integrate with existing uncrewed aerial vehicles platforms. The agreement will see physics AI develop advanced AI agents that can harness and identify changing wind conditions, optimize mission planning, and allow UAVs to soar like birds through various environments. The news for today. We hope you have enjoyed the news. Please do subscribe to our channel and do give us your feedback. Thank you.